Okay, so everyone's attention back up here. Networks today. Networks. Like I said, make sure you're focusing on the directed versus the finite graphs. Okay? We're going to try out this tablet deal, which allows you guys to write on the screen. Oh, I know. It's pretty cool. Okay? So I can't see where the little pointer is. Can you guys see it?
It's at the bottom. It's at the very bottom.
It shouldn't be at the bottom.
It's on the that's your mouse. Oh yeah. You already broke it?
Yeah, I already broke it.
Did you click it?
Oh, hey, there it is.
Good job.
So, this will, I really don't like having to be up here and teaching under here, but it'll allow me to write on here, and there's a bit of a learning curve. So, that's pretty cool, right? Okay, but you guys, I will be handing this to people today and having you write on the screen.
Yes.
So, do your best. I'll explain how to use it as we do it, and you can erase. It takes a little.
Wow. There you go.
Yeah, that's pretty cool.
Can you draw Mr. Vogel's stick plane?
Yeah. Not amazing at drawing the stick plane. So, one of the new things you'll see up here is on the actual screen, you see the so if we're looking at these pictures here on page 128, all right, number 2, what do the zeros along the main diagonal of the matrix represent? Yeah.
It means you can't go from the same points to that same point.
Okay.
Like you can't go from N1 to N1 because it's the same.
All right, so you can't go from N1 to N1. All right, you can't go from N2 to N2, and you can't go from N3 to N4. Yeah, we're dealing with the diagonals, right? So let's see if I can make this work. That guy right there, it's not a good circle, okay? But hey, if I'm looking at that node or that vertex to that vertex, it's very tough to draw, okay?
You can just look down and draw it.
I could, except for it doesn't help because I can't see anything on it.
Oh.
That makes it a little tougher. All right, okay. But that would mean that there's not a direct path between them. Now tell your neighbor what type of graph are you dealing with here? Is it directed or finite? Finite. How do you know it's a finite, not a directed? Yeah. Nope, it's not the x and y axis. Yeah.
The points are connected by, the points are connected by paths.
Okay, the points are connected by paths, but in a directed, they're connected by paths as well. Austin?
There are no arrows.
There are no arrows, right. So a directed shows if it was a directed, it would actually have arrows up here, okay? Now, I'm not going to be able to erase anything there, but, right, so if it were directed, I would actually see an arrow here, okay? I can't draw an arrow, obviously, but I would have an arrow right there. It's not directed, therefore there's not an arrow. Okay, what do the zeros in position 4, 1 indicate? Go for it, Jaden.
Can't travel between N1 and N4.
Good. You can't travel between N1 and N4. So 4, 1 is right there. I have no idea what I just did there, but it's right there. Okay? So you can't travel between node 4 and node 1. All right. Parker, you ready? All right. How many have done number 4? A and B? All right. Need a volunteer to draw it?
Oh, right here, right here, right here.
Oh, right here, right here, right here. All right.
Right here, man.
Okay, you try A.
I got A.
Go ahead and try to draw it on there as best you can. You gotta, to draw, you have to push. Let's see this real quick. Parker, here you go. Yep. All right. Hey, a very quick instruction on this. This is the pen you use. It will not. You don't have to like stab it or you break the pin. If you push the little button, there's a, I don't know if you guys can see that, but there's a switch right there. This piece right here, in order to draw, you have to push down on this right here. Just hold it down. Hold it down as you're drawing. Okay? Otherwise, it creates a lot of other problems, which I don't want to deal with. So, we're going to let Hannah do her best drawing there.
Master.
All right. We will stop recording while we're drawing. Oh, hold on. Can you not do that yet for a minute?
Yeah, my bad.
So I can pause. Go ahead and lift your pen away from the. Okay.
It takes away.
Where is there? Okay.
It's not too bad.
That's Hannah's. Is that for A?
Yeah.
A. I think that's supposed to mean. So.
Sorry, I didn't put a matrix like A.
0, 1, 0, 1, 0, 0, 0, 0, 0.
Yes.
Okay. I'm going to also show. I'm going to also show Jaden's. Okay. So let's see if we can get that up there. That's what Jaden has. It's a little neater, I guess, if you do it by hand. Okay. Thank you, Hannah, for trying that. So it says from N1 to N1, we don't have any path. If there was a path, there would be a curl right here. We don't have it. From N1 to N2, there is a path. From N3 to N1, there's not a path. Okay? So from N2 to N1, we've got a path. From N1 to N1, we don't. And from N3 to N1, we don't. To N2, okay, we've got a path. N2 to N2, we don't. N3 to N2, we don't have a path either. And then from N3, we don't have a path to anything. Well done, Jade. Okay, and then the next one. N1 to N1, we have a path. N1 to N2, we've got a path. N1 to N3, we have a path. And N1 to N4, no path. Now notice the two different ways I did that. Okay, one time, I tried to go this way and go N1 and kept skipping around. Down here, I was picking a node and then testing all the others. So from N2 to itself, or N2 to N1, there's a path. N2 to itself, there is none. N2 to N3, there's no path, so we put a 0. And N2 to N4, there is a path, so we put a 1. So a 1 represents a path, a 0 represents no path. Okay? Any questions on that? Everyone's matched Jaden's here?
Yep.
All right, very good. Okay, next one. Numbers 5 and 6. That's what we have. Okay, in the directed graph, what does the arrow to the hospital mean? Volunteer. Tyler.
The arrow. That means.
The arrow.
Means arrow.
What does?
It's a one-way road from the apartments to the hospital.
Good. From the apartments to the hospital. Sorry, you didn't see the rest there. It's in our book. All right. From the apartments to the hospital, it means there's a one-way road from the apartments to the hospital. Okay, we can't go backward. Okay, it's not two directions. How is that shown in a matrix? Well, from the apartment to the hospital, we have a 1. How about from the hospital to the apartment?
No.
It's a 0. Okay? All right. In example 2, what does the value C13 represent? C13. Yeah, Cole?
It represents that you can go from. Hold on one second. C1. Oh, that means that you can go back to one between the fire department and the whatever was.
The apartment?
The apartments. Yeah.
Good. From the fire department to the apartment. That 1 represents that you could actually move from fire department to the apartment. Can we go from the apartment to the fire department?
Nah.
No. Okay? Shown in the graph with just that single arrow. All right, so a directed graph actually allows you to move one direction or the other, not the band. Okay? Yes?
So if you wanted to show like both directions, how would you write that in the matrix?
If I had an arrow here, like that,
It'd be 2 directions.
Yeah.
then that would mean from A to F, I would have a 1 right here. That's how that would change.
So it's just one. It's not like.
Just a 1. Yep. So it's either ones or zeros.
Which is like some encrypted code, right?
Yeah, that's computer language, but that's not what we're dealing with.
Well,
Okay.
Networking.
Number 7. How many have finished number 7?
Nope.
Okay, I want you to finish number 7 right now if you can. If you put your letters differently, then you might get something a bit different. So you've got to really pay attention to what order you have them in versus what I have here. So P, Q, S, T. So this is alphabetical. It's probably the easiest route to go. That way we're all on the same page. This is this is Chloe's here. Okay? So 0. So from P to P, there's nothing. From P to Q, there's a route right here. From P to S, there's not a route. Okay? The directed arrow isn't going that way. And from P to T, there should be a route. From Q to Q, no route. Q to P, no route. Q to Q, no route. Q to S, we've got a route. And Q to T, QT, aw, there's a route. S to S, or S to P, S to P, there's a route.
Does T to P work?
SQ, there's a route. S to S, none. And S to T, no route. And we've got T to P,
TP.
good. TP, unbelievable. How immature. Okay, T to Q, no route. T to S, there's a route. And T to T, no route. Okay. All right, any questions there? All right, a bunch of ones and zeros, right?
Yes.
Okay, let's actually try to draw the graph now. I know, that's fun. Okay, there we go. Try number 8. Okay, so Alyssa has A going to itself. So I'm assuming she put A, B, C first. You have A going to itself. You have A not going to B, right? So we should have this piece gone.
Oh.
Got an eraser.
I know. That's what I'm talking about.
So I'm going to erase that. All right, and we have A not going to C. So we're going to erase this piece. All right. We do have B going to not itself, or B is not going to A. So we shouldn't have this line at all, I don't think. All right, we do have B going to C, though. All right. C goes to A, B, and C. So C goes to itself. So we need to have a point here going to itself. We have it going to B. And we have it going to A. That would be our directed matrix there. So this whole line, I think was good, really, except for that line. Okay? Thank you, Alyssa. All right, letter B. You know what? I'm going to do letter B up here. I know.
Can I do it on the board?
No, here we go. We're going to put P, Q, R, and S. All right, everyone help me out here. So P to P, how do I do that?
Circle.
Circle. Okay? P to Q. Line. Where's the arrow go?
Towards the road.
Towards the Q. Good. P to R. Okay, and P to S. All right. Now we go to Q. Q does not go to P. Okay, Q does not go to Q, but Q goes to R.
Q does not go to S.
Okay, R. So I'm going to focus on the ones here. So R goes to P. R goes to Q.
R goes to S.
R goes to S. S goes to Q, R, and S. So S goes to Q, S goes to R, and S goes to itself.
Does it matter what order that we have it?
Nope. So number 9, which one of those matrices does that directed graph represent?
Wait, what?
Which one of those matrix, or which matrix represents this directed graph?
B.
Tell your neighbor which one and why. How you know? How do you know? Okay, how do we know first? Which one is it?
It's letter B.
How do you know?
Because if you're testing, like letter A, you have L to L, which is 1, and it goes in circle, and then you go L to M, and it says that L goes to M, but L does not go to M, M goes to L.
Okay, so that right there tells you for sure. Okay? And we can find other spots in there, but that for sure. Good. All right, any questions? Everyone rate themselves 1 to 5. Okay, I need you to take out Thursday. There's a lot of times we get questions, when are we going to use this? You can use this a lot in cost analysis. It helps with product flow or optimizing schedules. Like if you're shipping, it helps if you have routes in mind. You're able to map those routes and know you can analyze the different efficiencies and the ability to move products from point A to B. Okay, so it helps with that type of analysis as well. Let me know if you have questions.